All right, here starting with video segment one of week one. I'm going to take a little bit of a review time here to go over chapter 6, which was earthquakes and Earth's interiors. We're going to focus mostly on the earthquakes. When we look at these objectives, I've scaled down this PowerPoint. Looks very similar to the one that you had. I just scaled it down and scaled down the number of objectives. To see the full PowerPoint, just go to the slide. You should have the link to it. So objectives, we're going to look at being able to define what an earthquake is, look at the key terms, what happens with an earthquake. Then we'll look at the different types of seismic waves, and then look at the actual destruction and hazards that can be caused by an earthquake. First of all, when you talk about an earthquake, it's basically a vibration. It's the ground shaking. It's a release of energy. That energy comes from the fact that the earth has plates on it, and those plates are moving and grinding past each other, and they become locked for a number of time because we're talking about solid rock. As that becomes locked up, stress builds up, and eventually it has to release that, and that is what we find in the form of an earthquake. Usually it will spring back, and that vibration is going to be what is the actual earthquake. And when you look at it, earthquake's it never comes as just one. It's like throwing a pebble or a rock into a pond. What you end up getting is multiple waves that are produced from this. So when we talk about an earthquake, it's actually just the largest one. Anything that comes before is called a foreshock. Anything that comes after is called an aftershock. So we technically don't know what the earthquake is or the magnitude of the earthquake until we know all of the series of events that have taken place. And how do we know what takes place? Is we look at the study of these waves, and we look at a seismograph. On the seismograph basically is going to be a recording of a pen or some type of recording system, and the ground moves underneath of it, and it's going to create a wave of types on a seismogram. When you look at a earthquake, most of the time the earthquake is not just at the surface. In fact, most of the time it occurs deep within the earth, the actual place where the waves are originated from. And we call it the focus, the place in the Earth's interior where that originates. And then the point directly above the focus is called the epicenter. And the epicenter is where going to be, obviously, it's the closest to where the release of energy was. So it's going to be the strongest amount of release. And usually the epicenter is where you're going to have the most ground shaking and the largest destruction. Not always. There's lots of factors that we'll get into that can cause destruction during an earthquake. But usually the epicenter, because it's the place where there is the largest amount of ground shaking, is going to be that. Just a visual that you get here. You have the focus at the earth, and the fault is the place that had moved. We can either have the hanging wall move up or the footwall move down. But there is movement along this fault, which probably caused these mountains, this fault scar up here. But the focus is in the Earth's interior. The epicenter is directly, a straight line directly above that. It may not be where the fault actually shows up as being part of the Earth's surface. The epicenter is still going to be the strongest movement and shaking that takes place. Well, with an earthquake, like we explained it as being a pebble being thrown into a pond, that these are waves being produced. And they're all produced at the same time. There are three major waves that we end up getting, two different types. One type is the surface wave, and the other type is the body wave. With the body waves, you end up getting two different waves. One that's called the P wave, the other is called the S wave. The P wave is called the primary wave. It's basically how they move. They move by compression. It's more of a vibration by a compression, which would be more like sound. It's a push-pull. These things can travel through the entire Earth, solid, liquid, gases. It's more of a pulse that gets generated when the earthquake happens. They move the fastest because they're technically not moving as much ground. They're just compressing and refracting. As you can see there, it does create damage, but it doesn't have as much because it's a compressional force.